In this video, let's see what do you mean by a scalar potential or the scalar function phi. Here, it's a continuation of previous video where we have proved that f is irrotational. Here they have given that f is irrotational and they are asking you to find a. After finding a, we have to use this clue, that is f vector is del phi, and we have to find phi from this clue. First of all, to find A, we use the first clue, that is curl of F vector is 0. Curl means cross product, that is del cross F is 0. So we have I, J, K in the first row, del by del X, del by del Y, del by del Z in the second row. And here is the I coefficient. What is that? AXY minus Z cube. This we have written here. Similarly, A minus 2 X square. This we have written here. And 1 minus A X Z square. This we have written here, and this is equal to 0. And we are going to expand this determinant. As I told you, leave this I row and I column. Left is del by del y of 1 minus a into xz square minus del by del z of a minus 2 x square. Similarly, minus j into, leave the j row and j column. So what we will have, del by del x of this term. So del by del x of 1 minus a into xz square minus del by del z of this into this. Del by del z of axy minus z cube. And your last term plus k into your last row will be there. Leave this k row and k column, and left over is these two. So del by del x of your normal determinant a minus 2x square minus del by del y of axy minus z cube. We have to simplify this, and this is, remember that this is already they have given it's equal to 0. So just we have to simplify and equate the terms. And when you see the first term with respect to y, if there is no y term here, everything is a constant. So I into first term will become 0. Okay. Minus del by del z of. And there is no z term. So here also it's 0. Minus j into. Let's see what happens to the next term. 1 minus a into x into z square. So 1 minus a z square is just a constant. X differentiation is 1 minus del by del z of axy differentiation is 0 minus 3z square. Second term is also there. And your last term, that is k. Of course, k has x terms, right? A minus 2 into x square differentiation is 2x. A minus 2 into 2x minus, with respect to y, ax. And then the other term will become 0. This is equal to 0. 0 I can write it as 0i plus 0j plus 0k. So we'll be equating the I with I, j with j, and k with k. So this is also 0, this is also 0, leave it. And the j term has a negative outside. So minus of 1 minus a z square. Second term will become plus. This will become plus and one more minus is outside. Better I'll write it like this. 3z square is equal to 0. Again, second term is a minus 2 into 2x minus ax is equal to 0. Because I'm equating I with I, j with j, and k with k. And now I've simplified this. From this term, this minus is there. Minus of 1 minus a will become a minus 1. I have written. And this minus and this plus will become minus. So this I have written minus. And if I take z square common from these two terms, first term is a minus 1, second term is minus 3. So a minus 4 into z square is equal to 0. Which implies z square cannot be equal to 0. So only condition is a minus 4 is equal to 0, which implies a is equal to 4. This we got from the first equation. Similarly, the second equation we got is a minus 2 into 2x. If you multiply this 2 inside, 2a minus 4, and then minus a. We are taking x common from this. So if you want, you write one more step extra, 2ax minus 4x minus ax is equal to 0. Now you take x common, 2a minus 4 minus a into x is equal to 0, which implies a minus 4x is equal to 0. And finally, x cannot be equal to 0, which implies a minus 4 is equal to 0, which implies a is equal to 4. So both the equations, anyhow you'll get the same answer. I'm just saying that you can equate any one and get the answer. If we have more than one unknowns, then you have to equate all. Now if you see, first term I term became 0 automatically. So we have used the j term and k term equal to 0 is already I, 0, 0. So we've equated to 0 and we got the answer A is 4. Now I will rewrite the given question f vector with the value A is equal to 4. Okay, now I have written the f vector. So this place A was there. I have substituted A is 4 and wherever A is there I have just replaced. And this is your question. In your question you have substituted A as 4. Now what is the clue they have given? F vector is equal to del phi. This means gradient. Del phi means gradient. What is the formula for del phi? This del phi is nothing but del phi by del xi plus del phi by del yj plus del phi by del yk. And this is your question f vector. We have equated this. So I am saying that something on the left hand side and the right hand side, the vectors are equal means the corresponding, the coefficient should be equal. So here del phi by del x will be equal to I coefficient 4xy minus z cube. Similarly, del phi by del y, that is the j coefficient, should be equal to 2x square. So we are not writing ijk, we are just comparing the coefficients. And similarly, del phi by del z is equal to, we are taking with the negative sign, minus 3x z square. So we got three equations. From these, we want phi. How do we know if it's a normal d phi by dx is given? Then we integrate with respect to x and we will get phi. But this is not a normal differentiation. When we get phi, when we integrate with respect to x, we'll add a function of c. But here, in the first line, we have to integrate with respect to x. Since the denominator is x. Second line, integrate with respect to y. Because first line, integrate with respect to x. Because it's partially differentiation with respect to x. And this we integrate with respect to y. And the last one, we integrate with respect to z. But one thing you have to notice, this is not a normal differentiation. Normal differentiation means we'll add a constant c. But here, since we are differentiating with respect to x, we might have treated y and z as constant. So instead of c, we have to add a function of y and z. Similarly, since we integrate with respect to I, we should add a function of x and z. Similarly, when we integrate with respect to z, we should add a function of x and y, because when I differentiate with respect to z, I would have treated this x and y as a constant. So be careful. First one, we will integrate with respect to x and then add a function of y and z. Second one, we will integrate with respect to y, add a function of x and z. And third one, we will integrate with respect to z and add a function of x and y. Finally, we will compare all the three answers. So let us carefully differentiate the first one. So phi is equal to integral of 4xy minus z cube with respect to x. So I have written dx plus I am adding a function of y and z. And here, if you have a doubt, this 4 and y are just constant, integral x dx. Minus z cube is also a constant, integral dx plus f1 of y comma z. So you are going to integrate only the x terms. The other things are constants. So 4y will be there outside. X differentiation is x square by 2. Minus z cube is there outside. Integral of dx is x plus f1 of y comma z. So here we will not write z power 4 by 4. Since we are integrating with respect to x, the z cube is just a constant. Now if you simplify, we get phi as 2x square y minus xz cube plus f1 of y comma z. Mark this is equation 1. Similarly, we are going to integrate the second term 2x square, this term, with respect to y. and then add a function of x and z. So phi is equal to integral of 2x square, and I will write dy, and I'm adding a function of x comma z. So if you do that, so 2x square is just a constant. Your phi will become 2x square into y plus f2 of x comma z. This is your second equation. You can see that some terms are common here. This term is common, this term is common. And then finally, you have the third equation. What is that? Phi is d phi by dz is minus 3x square. So minus 3x square, you are going to integrate with respect to z. So I will write dz plus add a function of x and y. So minus 3x is a constant. Z square integration is z cube by 3 plus f3 of x comma y. This is your equation 3, and you can cancel this minus xz cube. So your 5. So you got 3 answers, and we are just going to write the common terms only once, because when you see here the first function of y and z, there is only the function of y and z. You have to search in the second equation. There is no function of y and z here. But in the third one, also there is no function of y and z. In that case, function of y and z might be equal to 0. So that is what we have written here. That is f1 of y and z 0. So this f1 of y and z I searched. Now f2 of x and z I am searching in other places. So is there any x and z combination? Yes, we do have minus xz cube. So that is what minus xz cube is f2. And f3 is the last one. We are searching the combination of x and y. These two star terms I have mentioned already. These are combination. Same terms only will come. If it comes in the two different equation, two different terms will not come. Only same term will come. So 2x square y is the third term. So finally, we are writing it together. Or no, I can't think much. I don't want to search the function of y and z, x and z and all these equations. Then what should I do? Do one thing. Write the terms only once if it is more than once. So for example, 2x square y, 2x square y. We have written once 2x square y. Minus xz cube, and then one more minus xz cube. We have written once. And then is there any other term we missed? No. Every thing is f1, f2 and f3. So more than once, if it comes, write it once. And if it comes only once also, you just mention that. For example, you may get a third term in terms of y and z, say y square z, in case if you get, you're not getting it, but in case you're getting it in only one of the equation, means there also this with this term you add plus y square z and then mention it only once. That's it. So this is how you have to find the scalar potential. So how we got this function of y and z means function of y and z is mentioned in the first equation, that you will search in the second or third equation. You can get it in any one of the equation. Here I didn't get any yz combo in the second equation, only xy combo is there. Again, there is no yz combination in the third equation. That is why I have written this as 0. Okay. So scalar potential. So we get 3 different answers. Write the common terms only once. And if there is nothing in common and it has appeared once, means include that also. That will be your final scalar potential. Thank you.